Welcome once again. So we are going to proceed further in set theory. In the previous videos, we have seen the definitions of sets, supersets, various operations on sets, their relations, etc. Now there is one more thing, that is complement of a set, that we have discussed earlier as well, that complement of a set is universal set difference with A. That means universal set minus A. That means if this is your universal set U and here is your set A, then all this shaded portion will form your A complement. So this is the complement of A. There is one very important result we will use frequently while doing mathematics, that is A intersection with B complement is A minus B. This is the result. And the proof is very easy. How to prove it? It is similar to the proof that we have done earlier. We will take one element from this set and we will show that the element is here. That means this set will be a subset of this set. And then we will take an arbitrary element from A minus B and we will show that it belongs to A intersection B complement. That means A minus B is a subset of A intersection B complement, and when the two subsets will be subsets of each other, they will become equal. So we start with, let X be an arbitrary element of A intersection B complement. This means X belongs to A and intersection, that means and X belongs to B complement. This means X belongs to A and X belongs to B complement. That means X cannot be a member of B. So that means X does not belong to B as X belongs to its complement. Now X is a member of A which is not in B. That means X is a member of A difference B. We have taken this arbitrary element X from the set A intersection B complement and now it comes into the set A minus B, proving A intersection B complement is a subset of A minus B. Now, moving other way, that means we will take element X from the set A minus B, let X be an element of A minus B. This means X is an element of A such that X does not belong to B. Now, X does not belong to B. That means, where is it? It is in B complement. So X is in B complement. X is in A and X is in B complement. That means X is a common element of these two sets, A and B complement. And when some element is common in two sets, then it belongs to their intersection. So this means X belongs to A intersection B complement. We have taken X from A minus B and now X comes out to be in the set A intersection B complement. Therefore, A minus B is a subset of A intersection B complement. We have proved that A intersection B complement is a subset of A minus B and A minus B is also a subset of A intersection B complement. That means these two sets are subsets of each other, so therefore they are equal. So A intersection B complement is A minus B. Now there is one thing, there is one table which will help you to prove questions of set theory very easily. What the table is? That means there is union or belongs to, then intersection and belongs to, then union and does not belong, intersection or does not belong. This table is very helpful to you. Wherever there are any two symbols from these three, then the third one is automatic. That means, suppose you say that X belongs to A intersection B. Now you are having belongs to intersection. So belongs to intersection is in the second line. So that means this and is obvious. So what you will get, X belongs to A and X belongs to B. Similarly, suppose I write X does not belong to A union B. Now, does not belong and union, these two are together there in the third row. That means and is obviously. So this means X does not belong to A and X does not belong to B. Even if you write, suppose X belongs to A and X belongs to B. Now, there are symbols belongs to and. Belongs to and is in the third row, so intersection is obvious. So this means X belongs to A intersection B. So this table will help you a lot in proving the questions of set theory. Now we move on to some questions from your NCERT syllabus, plus 1 NCERT syllabus. Suppose there in a school, I am writing in a school, there are 50 students in a particular class. In a particular class, 31 of them play cricket. 35 of them play football. Assuming that every student plays at least one of these two. At least one of these two games. Find how many play both the games. So this is a question from set theory. Here, total number of students in the class 50. 35 of them play football, 31 play cricket, and everyone plays either of the two games. Now, the story is that suppose we construct two sets. I'm running the statement, keeping in mind the numbers here. So, suppose we denote by C. Let C denotes the set of students playing cricket, and F denotes the set of students playing football. Now, what is number of students playing cricket? That means the number of members of the set C is 31. Similarly, number of members of the set F, that means number of students playing football is 35. What is number of elements in the set C union F? C union F means the students who either play cricket or football. As given that everyone plays one of the two games, that means it denotes the total number of students in the class, that is 50. What we are to find? We are to find the number of students playing cricket as well as football. Intersection means and. And we know that there is a formula for this, and the formula is NC intersection F is NC plus NF minus NC union F. This was the formula we discussed yesterday in the previous video. So number of students in the set C is 31 plus 35 minus 50. So it is 66 minus 50 means 16. So 16 is the number of students who play cricket as well as football. This was comparatively an easy question because there are only two sets C and F. Question becomes a little bit typical if there are three sets that involve three sets. So we take one question of that type. I will not write the complete statement, but I'll just state the statement of the question and then start proof. So suppose there is a family, there is a colony where there are some 700 families are there. I'm taking the statement from the notebook. Now, suppose there are three newspapers common in the colony. There are some families who prefer to have newspaper Tribune, and the number of such families is 242. There are some families who are used to have Indian Express, and number of such families is 240. There is a third newspaper distributed in the colony. The newspaper is Hindustan Times, and the number of families having this newspaper is 178. There are families who read Tribune as well as Indian Express, and such number of families is 72. There are families who read Tribune as well as Hindustan Times, and number of such families is 60. There are families who read Indian Express as well as Hindustan Times, and number of such families is 68. Now, question is, how many families are there who read all the three newspapers? So, there is a formula we have studied yesterday in the previous lecture, that number of elements in A union B union C is number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C plus number of elements in A intersection B intersection C. That was the formula. Now I denote these three families, these three types of families by three sets. So one is the set T. T is the set of all those families who used to read the newspaper, the Tribune. So number of members of the set T is 40. Similarly, I is the set of all those families who used to read Indian Express, and number of members of I is 178. Similarly, it is NT here. It is NI. I skipped one. It is number of members of the family Hindustan Times. Then this 72 is for Tribune and Indian Express. There is and. So we will have here intersection of T and I. So number of members of T intersection I is 72. Number of members of the set T intersection with H is 60. Number of members of I intersection with H is 68. And now I am doing this now. We are having the number of elements in each of the sets. And what about this 700? This is the number of elements in the set T union I union H. Again, we are assuming that every family read at least one of these three newspapers. Now the formula we have seen yesterday, that N of T union I union H is number of elements in T plus number of elements in I plus number of elements in H minus number of elements in T intersection I minus number of elements in T intersection H minus number of elements in I intersection H plus number of elements in T intersection I intersection H. Now look at whatever in this formula is given to us and what quantity is not given to us. We'll substitute the values. This N T union I union H is given to us as 700. So this 700 is equal to NT is 242 plus NI is 240 plus NH is 178 minus NT intersection I is 72 minus NT intersection H is 60 minus NI intersection H is 68 plus this is not given to us and T intersection I intersection H. So to find this value, what we are to do, we will take all these quantities to the other side. So the value of N T intersection I intersection H will be 700 minus 242 minus 240 minus 178 plus 72 plus 60 and plus 68. So this is equal to now 700, and first I am adding these three things. This is 140 plus 60 is 200, so this is 700, and plus adding these two it becomes 200 minus. Now these three quantities are in minus, so let us take the sum. 242 plus 240 is 482, 482 plus this. So 480 plus 180 is 660, I think. I'm not sure. It is 660. And it is 900 minus 660 is 240. Let me check it once again. I think calculations problem will make the mistake in the final answer. So 700 and plus this is 200, 200 and 200, and this is 40, 82, there's 60, so 240, which does not seem to be correct answer, because number of families in two papers are 72, 60 and 68, so it should be lesser than that quantity. So actually in the question, the statement here is the number of families is 500. Sorry for that. So change this to 500. This is 500. This is 500. This is 500. And now it is 40. So 40 is the number of families who read all the three newspapers. Now there may be the question, how many families read exactly one newspaper? How many families read exactly one newspaper? There are two methods. One is the Venn diagram. So what the Venn diagram says. So here is, I am making the three sets, that is T, I and H. Now I am having the number of members who study all the three newspapers, that is 40. So I am starting from here. It is 40 here because this portion is common to T, I and H. This is the portion that is T intersection I, and T intersection I is 72. Out of 72, 40 is here, rest 32 will be here. Now this is the portion common in T and H. So common in T and H is 60. Out of 60, 40 is here, so rest 20 will be here. This is the portion common in I and H, and common in I and H is 68. Out of 68, 40 is here, so rest 28 is here. Now look at the set of T. Total number of members in T is 242. Out of 242, these are written here. So 242 minus 32 is 210. 210 minus 40 is 170. 170 minus 20 is 150. So these are the 150 members here. Similarly, for the set I, total number of members is 240. From 240, 40 are here. So 200, and 200 minus the 60 is 140 here. Similarly, for the set H, total number of members is 178. Out of 178, 28 are here. 150, 150 minus 40, 110, 110 minus 20. So rest 90 members are here. If you are asked to find the number of families who read exactly one newspapers, so exactly one newspaper means these plus these members. So it is 150 plus 140 plus 90, and the answer will be 380. So 380 families are there who study exactly one newspaper. But this is diagrammatically. If we are to find it analytically, then in the previous video we discussed that number of families with exactly one. Exactly one means T but not I and H, I but not T and H, H but not T and I, and it was equal to NT plus NI plus NH minus 2 times T intersection I minus 2 times T intersection H minus 2 times I intersection H plus 3 times T intersection I intersection H. This was the formula we saw yesterday analytically. So substituting the values here, NT was 242, then 240, then 178 minus 2 times 72 minus 2 times 60 minus 2 times 68 plus 3 times 40, and solving this you will get exactly the same answer, that is 380 are the families who read exactly one of these 3 newspapers. So one more thing I like to discuss before ending the chapter, that what is the basic difference between these 3. This is the open interval, this is curly braces A and B, and here is the closed brackets A and B. Actually, all these 3 are sets. This is a discrete set containing exactly 2 elements, namely A and B. So here the number of members of the set is 2. Look at this. This is actually the set of all those real numbers that lie between A and B. This is the set of all those real numbers that lie between A and B. And the third one is again the set of all real numbers that lie between A and B, but including A and B. That means this is the set which is equal to union of the other 2 sets. This is the union of the other 2 sets. Here A and B were not included. So union with the set containing 2 elements A and B will become the closed interval AB. So this is the basic difference between these 3 sets: open interval AB, A and B within curly braces, and closed interval AB. So here I am stopping this video. The first chapter, that is set theory, is being completed. If you have any problem, you want to ask some question, you want some question me to solve, you can ask me question in the comment box, or you can send me your question on my WhatsApp number, that means 9041404543. You can ask any question related to set theory, because we have just completed the topic set theory. You can ask your problems on my WhatsApp number given here, and I'd like to thank you for liking my videos, for sharing this with your friends, with the students who are students of mathematics, especially 10 plus 1 students, and subscribing my channel. Thank you once again.